Next is Tadeh Hakopian with Seeing is Believing, using diagrams to communicate complex ideas with Python. Welcome, Tadeh.
Thank you. Hey, all. Thanks for being here today with me and online, wherever you are. So let's get started. And to kind of make it easier, here's the QR code for the deck. In case you want to keep up a few things, I have a long version, which is like the extended version, which is not going to be here today. But I do have the short version on display for the event and on the link. So both of them are on the link. The short version is the one we'll do right now. And the long version is like the extended director's cut that you can check out later, since it would take me a little longer than the time slot I have to go through it. So it's all there. I'll explain a few things along the way. Okay, and you'll see this QR code again at the very end, so don't freak out if you can't get it right now. So I'll give you 10 more seconds to capture it, and then we'll move on and have some fun. 3, 2, 1, cool. Here's an introduction a little bit about me. Tadeh Hakopian, currently a program manager at Amazon. I talk to people in design, product, engineering, and management about how to move our programmatic projects along. And to be a program manager, you gotta make a lot of documents, PowerPoints, and diagrams, and put out a lot of fires frequently. So I, like many of you, make all sorts of information to communicate ideas to as many people as possible. And I realized over the years that diagramming can be very useful if you do it right, and very harmful if you do it wrong. So today's talk is about how we diagram. And we'll take a step into the past with diagrams in ancient times with this example of a Ionian order. That's the one where it's like, like a scroll wrapped up in the column there. And the ancient Greeks would say, okay, I want a temple. It's going to be Ionian temple. And cool, let's do it. What is that going to look like? And they'll give something kind of like this. It's like they'll draw this in like the sand or on papyrus and saying, this is what you need to know in order to build a Ionian temple. It'll tell you the roof, the corners, the entablature, which is the top half, the column itself, and all the details of the column, and then the base where the steps are. Not a lot of information, but with that information, you can literally tell somebody like masons and builders how to build an entire temple. And there's hundreds of these examples of different kinds of temples being built with a very simple concept of what it takes to build a scalable architecture with simple diagrams. It's really that simple. They always say, okay, here's the basics and please make a temple. And they're like, you got it, boss. And that's how you made these pretty elaborate temples. Okay, that was 2,000 to 3,000 years ago. This is an example of a modern plan for a building. And it is in fact a circle. Does anybody recognize something what this is? Raise of hands if you recognize it. Couple of hands up. Okay, you may know what this. It is, in fact, the Apple campus in Cupertino. It's a circle, and it's a very complex circle. It's a huge, huge building that they put into development, and the concept was like a unifying circle. So just like the ancient Greeks, this complex idea, this architecture came from a very simple point of view. And with that, you can very much elaborate upon, what they call ground figure relationships. What's that circle got to do with the landscape? What kind of landscape you want to put on? Pathways, all sorts of cool stuff. The access to the building and relationships. So that's pretty impressive that, thousands of years ago, you could build a building with a very simple concept, but even today, you can elaborate upon these ideas. Well, you think that would work as well for our software architecture diagrams, right? So here's an example of diagramming in the ancient past in the 1980s with notepad paper, where people are just doing simple system diagram with pen and paper, just kind of, drawing rectangles. So you think, that's a little crude, but they got the point across. They could do, all sorts of stuff back then with pen and paper, since they didn't have like good software on the computer to draw this stuff. They had to use the hands. Well, here's the diagram world we live in now. And so it's, I wouldn't say the evolution has been as sophisticated. It's kind of problematic, and I say we need to change. Because the diagram problems we experience today is they're flat, they're repetitive, confusing, like what am I reading here? And then the one-off, there's not a lot of reproducibility around it. So despite the complexity and sophistication we can work with today, we don't have really good diagram approaches. And I think good diagrams in and of themselves are good docs. because they matter. Diagrams matter because they help us communicate an idea. clarify ideas, provide technical information and documentation for a project or product. And in and of themselves, they are documentation. So even if you are just trying to get documentation across, you need a good diagram. Otherwise, you'll confuse the people you work with and communicate with. And because it's a Python conference, I'm going to give some Zen of Python. The beautiful is better than ugly. So we want to make good, appealing, beautiful graphics. And good, appealing, beautiful code and good, appealing, beautiful diagrams. And that will improve our code in general, whether you're doing textual code or anything else around Python. So with that in mind, we're going to talk about the good, the bad, and the UX. I'll go over some core fundamentals of UX, give you some examples, and then we'll go on from there. I think having this baseline of like the actual UX and graphic fundamentals will kind of help clarify the approach. And the core fundamentals of UX is to be clear, be concise, be useful. Clear, concise, useful. If you touch those points, you can solve a lot of problems. And that is explicit is better than implicit, another Zen of Python quote here. So rather than just give you those 3 points, I'll go into more detail and be more explicit. With graphic fundamentals, I'll follow through right now, which is 6 I put here, to help you kind of understand the fundamentals of UX in a little more structured way for diagrams, is hierarchy, structure, contrast, color, space, variety. Those 6. So we'll talk about those 6 and how you can understand what they're for. So first, hierarchy. Just a simple ranking, first, second, third, right? People kind of get importance through hierarchy, which is fine here, kind of like a totem pole, but you could also express the hierarchy and make it very clear with a visual representation, like a pyramid, where it's very clear which one's at the very top and which one's at the very bottom, and really get the point across if you're trying to express ranking and hierarchy. Next is structure. And structure is just simple enough. It's about making a clear, concise, easy to read example of a diagram, like this, where it's just blocks. The diagram scheme makes sense, but it's very awkward and kind of Jenga-like in its composition. It's about to fall over. So all you gotta do is organize that, clean it up a little bit, and make sure you're packaging that structure of a diagram a little better. Next is contrast, and that's kind of like weights and different tones. Here's how contrast is used by photographers in black and white. This is an example from film. They use different contrast to get like black and white film. It's very nuanced. And you could use contrast to your advantage when it comes to line weights and grayscale to, again, help express the graphic. Here's a diagram example. You might have seen something like this before, where it's just explaining, a document and string information on a database. Looks fine, black and white, but a little flat. If you use that contrast to your advantage, it pops out a little bit. You have a nice, clearly defined border, dark text, and the gray is a little easier on the eyes than just pure white space. A simple change you could make in most software for editing. But with that said, with contrast, you can also use colors. Well, oh, there it is. That's a little better. Colors. A nice little color gradient here. Colors are wonderful. I highly recommend using them because it's so easy to apply. And what's so great about colors is you have a whole world of them at your disposal. You can use, for example, more playful tones like these primary colors, kind of Lego-like. It really pops out. So if you use nothing but like white blocks all day in your diagram flowcharts, it might get a little stale. But if you think it's a little too strong, you can also go to pastel colors. And for those who have problems with color blindness, I have a little bit of yellow-green color blindness myself. You can use monotones, like this different shades of red here to kind of help make it easy to read the colors for people who have problems with colors. And you don't have to be an expert in colors. You can go online and get color schemes like Spring Pastels and generate hexadecimal code that will inform you of what looks good for different color compositions. So it's pretty easy to go and find these things for yourself. Next comes space. Space is very useful. It's the final frontier, of course. And the important thing about space is the relationship within the space. I've seen a lot of diagrams where people kind of shove everything together as though they're going to run out of paper when in fact it's just digital infinite space. So instead of having this kind of like Tetris-like composition, give a little breathing room. That way you can add context like flowchart arrows. Sometimes you're not sure what connects to what. So if you're going to start kind of laying out your diagram, make sure you give a little more room. You can always compress it later. Like we talked about with the first example, structure, you can always organize it later. And last but not least, variety, the spice of life. And there's lots of different ways of putting a diagram together. The principles of color and contrast and space are important, but like you can use linear diagrams, circular diagrams, divergent diagrams. Linear is pretty straightforward. There's a start and end, top down, left to right. If you just want to express a very sequence workflow, this is something most people can wrap their head around real quick, whether they're a technical expert or not. Radial is really great for expressing relationships. For example, there's edible food and cookies, and they intersect in certain points. Not all edible food is cookies, and not all cookies are edible. Some people really don't like raisins in their cookies, so they don't think it's edible, for example. So it's good to kind of give you a way to understand relationships in radial charts. And divergent, it's like a flow chart, but it will separate in different paths. If there's a flow chart where different paths go to different places, you've all might have seen something like this before. It's a kind of a Git flow diagram with master and branching paths. This is useful for us to track different changes in the code repo from different people on the team, but it's also a great storytelling approach to explain what is going on with a project or information within a project. People can see that some things are sequential, like the master, others kind of pop out and come back in, like the feature, and others are parallel, like the bottom feature. So that's the kind of principles that I'll use for design and UX. And that said, simple is better than complex. I didn't want to give this all to you and say you have to use all 6 of these all the time. Use what you need. Use it as far as you can take it. And keep it as simple as possible to make it as easy to attain as possible. Whoops. Okay. Next, tools to make a diagram. So you might be thinking, cool, but how do we actually use Python for this at a Python conference? So what are we doing here? So let's go to some examples of using those principles, because principles are universal. You can use them with crayons and paper if you want to, right? So how do we do that with Python? Well, there's one module I want to start with using GraphViz, the diagrams module, and Python. And all you got to do is pip install diagrams into your Python environment, and you could start doing some cool stuff of writing Python code out that can then generate diagrams. So we'll go through a couple of samples. Here is a way we can generate cloud architecture diagrams with the diagrams module we just installed for AWS. So it's from diagrams, import diagram, and then you import from the AWS database in the diagrams module the different AWS components, EC2, RDS, ELB in this example. And from that, you can then write Python code to generate the diagram like so. So let's review this real quick to kind of follow along. At the top here, you have from diagram, grouped workers. That's the name of the entire thing. At the bottom there, you can see grouped workers. So you give it a string name, and then you'll say direction, TB, top to bottom. So it's flowing up from top there, down, and the top thing is ELB, the load balancer, which is then pointing arrows to all the EC2s. And in the code there, it's an array. EC2 worker 1, 2, 3, 4, 5. Each one is in a sequence with a string name, and you just have to make sure you have ELB for the load balancer with a string to given a name as a text string. You can see there in the diagram output. And then each of the EC2 instances, you just give another string for a name that you can see again in the diagram. And then you point that entire array out to RDS. You can see the arrows from ELB to the array of EC2s to then the RDS, which is the relational database. So in this case, all you gotta do is type this out if you understand the logic of the module, and it'll automatically generate the flow. And it'll give you the colors and the structure, and you don't have to do a thing. But if you do want to modify it some more, you can export this as a PNG, SVG, and go into an editor software to clean it up some more so you're not stuck with this if you want to make some changes. So that's one way of using Python code and Python modules to generate an actual diagram. That's pretty clean and clear, and you can modify it some more. So that's just one module. There's also Plotly for Python options. We talked about variety being the spice of life. You can't get more various than Plotly. There's a lot of great options for using diagrams. A lot of things you can do here for data science, and they have a whole Python-centric package. And one example is pretty cool, is the Sankey diagram. And the Sankey diagram, you've probably all seen something like this before. It's a series of kind of flows from left to right, where you can have different paths connecting and diverging into different streams. And you can actually create within Plotly, if you install the Plotly library to your Python and then import Plotly, you can create a Sankey type diagram. You can make many different kinds of diagrams. And all it is you can see the label there, A, B, C, D, E, F. That's the index that it references for the source, target, and value that you can then apply. So A, for example, is 0. It's the source is 0. Target is 2, which is C, and the value that A goes to C is 7. So it's pretty easy to manipulate real quickly to make a diagram for you through a Python code, and you can change the colors and everything in here pretty quickly if you want. Right now it's set to blue labels. So if you see A, B, you see all the letters, they have a little blue rectangle next to them. You can change that to yellow, red, whatever is in the library to manipulate. It can be more sophisticated with using different features. You can make more sophisticated Sankey diagrams that are have divergent paths and loops. In this case, you can actually position the different labels. In this case, you can see the same thing, A, B, C, D, E, F. And then X and Y is actually Cartesian coordinates. You can manipulate as a different set of variables beneath it. Then again, you set the source, target, and value, and they can go in different patterns. You don't have to be able to draw this. You can use the Plotly library with Python to create this yourself. That's a neat way to create both a linear and divergent set of graphs. Next is PyFlow, which is pretty cool. What PyFlow does is it uses a low-code visual script version of Python. This is all Python. And what's neat about it is that you can show the logic of your Python script without having to actually textually write it out, which is good for actual real script, like in this case, assigning integers to an array, or pseudocode, which is helpful if you're just trying to show logic to a group of people. And this is pretty much a diagram in and of itself. And you can manipulate the different strings or different wire connectors between the different nodes. So that's an example of space. You can move it apart, you can bring it closer, it all automatically adjusts on the fly for you, so that's pretty neat. And you can also adjust the different wires to be either curved or straight, depending on your preferences, so it gives you some more control of that. This is a great way to kind of show a concept without having to have everybody read your code in text from top to down. This is a little more just, giving the logic. Okay, that said, there's lots of other tools out there, but don't forget, complex is better than complicated. So complex implies there's some kind of logic and reason to it, and complicated is just kind of hard to interpret. With complex, I recommend if you want to go to a higher level than just a one-off diagram that we've been seeing, the C4 model diagram system by Simon Brown is a great way to do that. It is a way of visualizing software architecture as code, just kind of like what we're seeing here, but it specifically generates the C4 software architecture diagrams that Simon Brown built with his own code blocks. So for example, it's the entire software architecture system that then goes to containers of different apps you would have in that software architecture. That goes components and then the code itself. And this is all a visual version of how you do it. And he does have a do-it-yourself system called Structurizer that uses its own logic to create code just like we saw with the other modules. So check this out, it's really cool. It basically gives you the software architecture master plan version of what we just saw with simple diagrams if you want to take it a level higher. And you can actually combine this with that first module, MinGrammar, and it has its own Python module for C4, so you can actually combine the C4 model with the original diagrams module and then create more elaborate diagrams that are matching the C4 architecture diagram system, which combines his Simon Brown's structure of hierarchy, structurizing the code so it's nice and clean, and space planning. It's all built in for you, so if you don't have to think about it anymore, he just kind of organizes that system. That's his solution. And then we have a bonus round, right? Pretty fun, bonus round. Yeah. And that's going to be Mermaid. If you have it, Mermaid is Mermaid or Mermaid.js is a system where you use Markdown, not even Python, so Markdown language to create diagrams. So the text on the left that goes into a Mermaid module can then generate a diagram real quick for you. And it has all sorts of variations. It could do linear, top to down, left to right, radial, bars. It could do divergent, kind of get branch looking things. It does all sorts of stuff. This is just a state diagram going top down. And you could quickly write out the logic with using arrows like this one, where A leads to B, and you can actually add content as a part of the arrow going down, and then B leads to C deploy, and then C leads to D, E, F, which are different servers in different cities. You just write this text out, you put it into the Mermaid module, and then it creates this diagram for you. And what's cool about Mermaid is it's everywhere. You may not have noticed this, but it's literally in every one of the graphic editing software you'd probably use, except maybe Photoshop and Illustrator. It's in just about everything else, including, say, Lucid Charts, Miro, Figma, all sorts of stuff. So you can actually take this text right here and put it into anything that has a Mermaid module or online generators and get the graphics out of it. And what's even cooler is that you can take these graphics, manipulate them to apply those standards of UX design, and spit out even nicer versions of them using, manipulating the graphics. So Mermaid will only give you the example on the left. It won't edit anything further to you, but you can manipulate them yourself. And one way to do that is take Mermaid, the tool, the textual tool, with Draw.io, input the text, put into Draw.io, which is another software-based diagram editor, and you can change all the graphics. I would love to show it to you right now, but we're running out of time. So that's going to be a bonus round, is to check out the long version of the deck. It'll show you all the steps of taking that markdown language you just saw and editing it in Draw.io to change the thickness of the lines for contrast, color schemes, all sorts of cool stuff. So check that out to see how you can take the automatically generated diagrams and make them a little nicer and cleaner to your preference. So some do's and don'ts. Do make graphic choices salient to your project that makes sense and you feel is a good way to describe the information. Do use common formats of diagrams like linear and diverging, whatever makes sense, so that people have an easy time interpreting what you're presenting to them. And do use editing tools, whether that's a Python generated code, Markdown generated diagram, or editing software like Draw.io to help you out. Don't struggle with this stuff. Don't be excessive. Don't put too much in one single diagram. Spread it out. Don't feel like you have to put everything on top of each other. Don't be tangential and kind of create a very elaborate diagram that is hard to interpret. Again, make it as simple and straightforward as possible. And last but not least, don't use Visio. Friends don't let friends use Visio. Everything I showed you is free, so just use that. You don't need to spend a fortune on that. All right, closing thoughts. Fundamentals review. Be clear, be concise, be useful. Don't make it any more complicated than it has to be. But do get a point across with every one of your diagrams. Review the graphic fundamentals of hierarchy, structure, contrast, color, space, variety. Use them all, use as many as you need. Just be mindful that they're principles to help you kind of figure out how to express your thoughts on a visual side. And a call to action to all of you. Get examples of diagrams you like that you thought were good ways of explaining a complex subject or just displaying information. And reinvent your process. Think, what makes sense to me to edit my documents and diagrams? Should I use the Python-based examples? Is there another tool? What's my color scheme? How much should I spread them out? Think about how you want to do it. It's pretty easy to jump into it. And make or rebuild or remake some diagrams yourself if you already have some on hand or your team has some at hand, and see if you can make a better version of what you already have. Because trust me when I say that there's diagrams and some are pretty bad and some are better. So maybe elevate your game a little bit with the diagrams. And here's some of the tools we talked about today in the deck. Again, you'll get the QR code for this in a moment. So Minigrammer diagrams, package, PyFlow, PyDoc, Mermaid, Draw.io, and a bunch of other stuff, including Structurizer, C4 by Simon Brown, and a few other tools. And references for thoughts and ideas about how to make better diagrams. There's Zen and Python, which is a really good kind of baseline for you, color scheme approaches and how you make a good palette, design choices, and of course the C4 model by Simon Brown. I keep bringing up C4 model because it's a really well thought out system architecture design schema, including tools to help you use it. So check that out if you're thinking about bigger picture stuff than just what I showed you. And of course, beautiful is better than ugly. I want to revisit that. I've seen a lot of beautiful things in the Python community and here today at PyCascades. So I'm always interested in spreading a little bit of beauty and joy into the world, so I hope you do as well. And that said, there's your QR code if you want the deck. I'll leave that up there for the rest of the talk. But thank you so much for having me here at PyCascades. You could have been anywhere on the world, but you decided to be here with me, and I appreciate that. Yeah. Thank you.